Okay, in number 3, we're just sort of upping the ante from number 2 because now I've got an x squared up top. In 2a, I just had a 1. In 2b, I had an x. Now I've got x squared over x squared plus 25. What's the strategy now? Well, since the degree of the numerator is equal to the degree of the denominator, we can do some long division. If this were an x cubed or an x to the 4th, we would also do long division. So anytime the degree of the numerator is bigger than or equal to the degree of the denominator, the first step is always the long division. So I'm going to take x squared plus 25 and divide that into x squared. So x squared times what gives you x squared? 1. And we can do the usual, fill in the missing powers of x here. Oops. So we can have a placeholder if we need it for the x's and the constants. So the constant 1 goes there. I multiply x squared plus 25, and now I subtract just like in regular division. X squared minus x squared is 0. I don't collect any x's. I have minus 25. So the remainder is minus 25. That means I can rewrite this as an algebraic kind of mixed number. This goes in one entire time with the remainder of negative 25. So it's the remainder over the divisor, just like it is in regular arithmetic. That means this integral I can rewrite as 1 minus 25 over x squared plus 25 dx, which means I can break this up to the integral 1 dx minus 25 times the integral 1 over x squared plus 25 dx. The integral 1 dx is x minus 25, and as we talked about in number 2 part A, this is just 1/5 arctangent x over 5 plus the ubiquitous arbitrary constant of integration. And so for my final answer, I get the integral of x squared over x squared plus 25 is equal to x minus 5 arctangent x over 5 plus c. So that'll do it for 3a. Okay, part B now. We've got an integral 1 over x to the 4th plus 25x squared dx, which is the integral 1 over. We've multiplied the denominator now by x squared. So this is going to be one that we do by partial fractions. So the first step is to factor the denominator. And remember this x. We can think of this x as the quantity x minus 0 squared. So we treat this as a repeated linear factor. This, on the other hand, is an irreducible quadratic. And you should just know from algebra there's no way to factor x squared plus 25 without using imaginary numbers. But when in doubt, you could always go through the discriminant. All right, in this case, the discriminant's negative 100, and anytime the discriminant's less than 0, that's going to give you the irreducible quadratics. Okay, so to proceed by partial fractions, we need the form of the partial fraction decomposition. Keeping in mind x squared is a repeated linear factor, I know this has to look like a over x plus b over x squared plus, now for the irreducible quadratic, cx plus d over x squared plus 25. Now remember, the partial fraction decomposition, we're reversing the process of getting a common denominator. So I have to think of what possibilities there are of fractions. What are the possible combinations of denominators that would give me this as the least common denominator? So we have x squared, and x squared plus 25. All right, so the next step is we multiply both sides of this equation by this common denominator. If I multiply the left-hand side by the denominator, I get 1. On the right-hand side, one factor of x cancels, so I've got ax times x squared plus 25. Here, I'm left with x squared plus 25. And here, I've got cx plus d times the x squared. All right, now, I could choose x equals 0. If I plug in x equals 0, that's a good choice for x. On the left-hand side, I'm going to get 1. I plug in x equals 0 to the first term. That's going to zero that out. I plug x equals 0 in here, I'm going to be left with 25b. If I plug x equals 0 in here, that zeroes out. So this tells me that b is 25. Excuse me, not 25. 1/25, 1 over 25. But as far as picking values to zero out other things, unless I dip into the imaginary numbers, I'm pretty much stuck. So at this point, what we need to do is look at the coefficients of x and the powers of x on each side of the equation. So the highest power of x that's going to come out of all these multiplications is x cubed. So what we do is compare the coefficients of x on the left-hand side of the equation with the coefficients of x on the right-hand side, and we start with x cubed. That's the highest power of x that's going to show up all the way down the line. So the left-hand side, the coefficient of x cubed is 0, x squared is 0, x is 0, and the constant's 1. Now we look at the right-hand side for x cubed. When you multiply this out in the first term, we get ax cubed plus 25ax. So I'm picking up a factor of a there, plus, I'm not going to get any x cubes from this multiplication. Here I got an x squared times cx. That gives me a cx cubed plus a dx squared, so I'm going to pick up a c from there. Moving on to x squareds, there's no x squareds that come out of this multiplication, but in this term I get a bx squared plus 25b, so I do pick up a b there, and I pick up a d here. Now for the x's, here I got 25ax, no x's here, no x's there, and finally for the constant term, I get 25b for the constant. All right, so this gives me a system of 4 equations and 4 unknowns. I know that a plus c has got to be 0. I know that b plus d has got to be 0. I know that 25a has to be 0. And I know that 25b has to be 1. Now this equation here is actually the same equation I had down here. This gives me b is 1/25. This equation gives me a is 0. I can plug this back into the first equation. This says that c is minus a, so that's got to be 0. And I can plug b into this equation. D is minus b, so that's got to be minus 1/25. So the partial fraction decomposition will always give you a system of linear equations when you equate the like powers of x. But what's all this mean for our integral? If I plug these values back in, I've got 1 over x to the 4th plus 25x squared is equal to a over x, but a is 0. I've got plus b over x squared. The b is 1/25 over x squared plus cx plus d over x squared plus 25. c is 0, d is negative 1/25. So that means if I want to integrate this, I'm going to integrate these. So I've got 1/25 integral 1 over x squared dx minus 1/25 integral 1 over x squared plus 25 dx. And we know both of these. The first one is a Calc 1 integral, power rule, negative 1/25th, x to the minus first, so it's minus 1 over 25x, minus, this is our friendly arctangent form. I've got a 1/5 that's going to come out as a coefficient. Multiply that by the 25 that's already down there. I've got minus 1 over 125, arctangent x over 5, plus, of course, the c. So that'll do it for 3B, and that'll do it for checkpoint quiz 9.